Okay, so let's look at, it's called, no, not this one. Okay, this is from here, right? So,
Yes.
so now we look at this pointer here. So this pointer will be append. So let me actually just comment this, is that suppose somewhere here, you should have a line says VCC reaction PTR is equal to, I think it needs to be equal to new VCTOR reaction star. Sorry, this is vector reactions star. Yeah, you need to have something like this. You need to have a line looks like this. So you will create a new vector, and then the create using new, which means you return a pointer, and that pointer will assign to this one. And then inside here, you can actually do the append to this pointer, and at the end, you put it there, it will be there. Okay, you should have this. So I'm going to unshare my screen just a moment. Let me actually double check with my real version to see if I do have that, okay?
I did it like that, and then the error went away.
Oh,
You still
really?
use the do you still use the arrow? Like or the dot pushback? Is it arrow pushback or dot pushback?
I'll check. But it was me who posted that Piazza post, and then what the professor just wrote, I did that like the other day, and then it was fine after that.
Do we have to do it for the tag 2 under it, or just for the reaction, the new reaction?
I think only for a reaction.
Okay.
Yeah.
Thank you.
And then it was dot pushback, not arrow pushback. The book also briefly talks about that too, I think.
Okay, so I'm actually going to put this one here. Just 1 second, I'm going to share my screen in 1 second. Okay, I'm going to share my screen. Hold on 1 second. So I check my code. So somewhere before this, I said I wrote down this one, and this is, I actually copy my own code. It's actually exactly the same. So you have to create this array. That because if you didn't create this array is a null pointer. It doesn't have the right address. So when you want to do append or pushback, it will causing segmentation fault because it doesn't have the memory to support that. This is for C, C++, programmer, this is something which we need to be very careful. And then the way I do pushback based on this construct is this line here. So let me just change this back so you can see the color. So I'm using star vec reaction pointer because it's a pointer. You can use, I think Jenny was mentioned, you can use the other notation is using, if you don't want to use that, you can do this as well. That should be okay. So there, either way. So what I did is I do this way.
I didn't use the arrow. I used that way too.
Okay, okay.
Yeah.
Yeah, we just use this way, then it will work. Okay. So is this does that answer your question?
Yeah. So was it because when we initialized the vector reaction, it was equal to no?
Right, right. If you do this, right, without initialize this, what you will have is that, in fact, it will not even try to do pushback. When they do this, is already segmentation fault. When you do this, when you try to do star VEC reaction, because VEC reaction pointer is a 0, that 0 is actually the memory address of a kernel space, which is operating system kernel. Is prohibited for us to access. And when you want to dereference a prohibited space, you try to see the content, that's called segmentation fault, because you try to access memory that either prohibited or doesn't exist. And that's why it is saying that you have a memory segmentation fault. So if you initialize this, so anytime you see segmentation fault, that usually for C programmer, anytime you see a segmentation fault, that means you try to dereference a null pointer, or you try to, for example, this will cause this line here. This will cause a segmentation fault if comment pointer is null. If this is a null, you try to use a null pointer pointing to a member reaction, you're also causing a segmentation fault. Yeah, so it's always some pointer or some address is not being set correctly, and which means that it's usually when I say it's set incorrectly, most of the cases it was a null pointer. And a null pointer is always, of course, the segmentation fault could be more complicated than a null pointer, but the most common case is the null pointer. Okay, all right.
Null pointer, is it? I didn't malloc it. I didn't allocate space for.
Yeah, null pointer you didn't allocate, but null pointer usually means this. Let me use this as an example, okay? Null pointer usually represent this, is that the address you have is a 0. By the way, you can write a code looks like this. You just say, I can just put a 0 here, right? I mean, wait a minute, sorry, star 0. And I will just put my casting voice star 0. Okay, so basically, a null pointer means the address value of an address is a 0. 0 is null, basically. So in this case, this code might still compile, but it will definitely give you segmentation fault. Like this, because it's a 0 pointer. When you want to dereference a 0 pointer, a null pointer is a 0.
It is a 0 pointer because we did not set a pointer.
Well, because the address is a 0. The address of this location is 0. So when we talk about pointer in C, the pointer really represents the address in the memory block. So the address is from 0 all the way to whatever memory address that you have. When you go through ECS 150, you will learn more about memory model. I'll probably can tell you more about this if people are interested. In Unix environment, that the memory address was nobody is prohibited area for address from 0 to about 1024. So that is an area which actually the address is not used by anybody. It's not used by user, it's not used by kernel. That address is purely reserved for saying that this is a prohibited zone of memory. And guess what? That was designed that way to go along with C programming language, was really starting from C. Because C programmer, the most commonly used, most commonly committed error is that they forgot to do malloc. They forgot to set the pointer correct, to allocate memory space. So when you didn't do that, you're going to try to dereference or try to reference a null pointer, which is the memory address of 0. And they will give you a segmentation fault just for that reason. So it started with that, and then we basically say, okay, the first page of the memory, which is from 0 to 1023, actually, sorry. The first page is the 1K page, is from 0 to 1023, and that page is unusable. That address space is completely unusable. It's just want to catch all the null pointer error, okay? And which you will say, okay, I'm wasting one page of memory. It looks like as if you're wasting one page of memory, but it's not, because most of the modern operating system were using virtual memory. So virtual memory means that the physical memory, you will never waste any physical memory. You just waste a little bit of your virtual memory, which doesn't cost anything to your operating system. I'm a bit too complicated into the ECS 150 concept, but there is the whole thing that C was designed pretty low level that they can address such memory layout issue. Yeah. Am I just causing you more headache or something like that? I'm sorry, I maybe carried away to talk about too deep into this issue. But basically, remember, when you saw the segmentation fall, that means you forgot to actually either malloc or new of a piece of memory regarding a pointer. Because this line, what this line did, okay, let me just tell you what this line did. This line did is when you call new, when you do new, that the library is going to find a piece of memory on your heap to, let me just say, this is actually on the heap. The library is going to find a piece of memory on the heap and then return the memory address of the first byte of the heap. So it will return the memory address of the first byte of the piece of memory you just allocate, okay? So allocate a bunch of memory, return the memory address of the first byte, and then that address value is going to assign to the vec C creator reactions pointer. So reaction pointer was null before this line, but after this line, it has a valid address. So without this address, you're going to see essentially doing this way, is just using a 0 address and try to do pushback, and you're actually hitting some area which is prohibited. And then the system will give you segmentation fault. But if you did this line, then you have a valid address. Then basically when you push back, is push it back to the right place, because there is a memory that's going to support this operation related to this pointer, and everything is fine. So that's what I was saying. Is that okay with everybody? Any follow-up?
Yeah.
Okay.
That was interesting.
Yeah. Yeah, there was some upper division classes. I mean, you will learn more detail about how the design of the language, especially C language. Basically, I don't know if you know this, that the first version of Unix operating system was developed in 1974, 1976 by a group of researchers from AT&T Bell Lab. At that time, it was called AT&T Bell Labs. And they developed the first version of Unix. And then when they developed Unix, they realized they need a higher level programming language to go with it to do the development. And that programming language is the C. So essentially, Unix, C, they kind of go together. They're being developed together. So there is a lot of culture that they're related to each other. Even today, there is still, I mean, like a Linux, most of the Linux code, or maybe C code, or maybe Microsoft operating system, they're basically being implemented in C. And so that's why there is some history there. You will see that why this has happened this way. Okay, I'm going to stop sharing and also stop recording.